We're now going to provide one more illustration about how inferential statistics is simply about looking at relationships between variables, that is, the relationship between x and y. You may recall we called that the canonical model. Are x and y related? You've seen this slide before. What happens to y when x changes? Does x affect y? Is there a difference in the y values for a different x value? Let's take a look at a sample data set. This is the same data set we've used before. Our x variable is sex, girls are coded zeros, boys are coded ones, and our y or dependent variable is maximum leg press. We're now going to illustrate how we could use a correlation coefficient, a t-test, or analysis of variance when you have two groups only, and this works only when you have two groups. You will arrive at exactly the same conclusion. Is there a relationship, or is there a difference between genders with regard to maximum leg press? Here's a couple of illustrations.
On the left, we show no correlation. There's no difference between the means for the girls and for the boys. So if you correlated zeros and ones with their leg press scores, the answer would be 0. On the right, we show two forms of when there is a relationship. On the top, we have a positive relationship because the high scores on leg press are associated with boys who are coded 1, and the low scores on leg press are associated with girls who are coded 0. Notice there's a difference between the means and also a positive correlation. The bottom slide shows exactly the same thing but in a negative direction because the low scores on leg press are associated with the high scores on gender, which is 1. The high scores on leg press are associated with 0 for girls. So we have a difference between the means, in this case a negative correlation.
Here we have the output from 3 SPSS procedures. In the top left, we have the result of a correlation coefficient, where sex was coded zeros and 1 and maximum leg press. The bottom two panels represent the results from an independent t-test, where the independent variable was sex and the dependent variable was maximum leg press. And the last panel is the result of an analysis of variance. In this case, we did an analysis of variance with two groups. We realize that we've basically been talking about doing an ANOVA when you have more than 3 groups, but you actually can do an ANOVA when you have 2 groups. And for our illustration, that's exactly what we've done. So we have 3 different ways of looking at the relationship between sex, coded zeros and 1, and maximal leg press. Let's take a look at these 3 outputs and see how they compare. Our first look is at the correlation. The correlation between leg press and gender is 0.034. Notice the probability is 0.740. That's with the correlation coefficient. What if we look at the t-test? Notice the probability that we get with the t-test. It's identical to that which we found with the correlation coefficient. Notice the probability that we get with analysis of variance. It's identical to what we found when we did the t-test and when we did the correlation coefficient. So this illustrates that in the bigger context of things, inferential statistics is about the relationship between variables. In one case, we related them with the correlation coefficient. Once we related x and y with a t-test, and once we related x and y with analysis of variance. This is a reflection of what's called, again, the canonical model. Is there a relationship between x variables and y variables? Another key distinction is if you look at the t value, the calculated t, and the calculated f. If you have 2 groups in an analysis of variance, and obviously you'll have 2 groups in a t-test, the t value squared is equal to the f value. Notice that the t-test is a special case of analysis of variance. The t-test has 2 levels of the independent variable. Analysis of variance with 2 levels results in exactly the same finding. That is, the t squared is equal to f, and the probability, 0.740, is exactly the same. So regardless, we have identical decisions that we've made, whether we use the correlation coefficient, whether we use the t-test, or analysis of variance, we draw the same conclusion. In this case, we retain the null hypothesis. There's no relationship between sex and maximal leg press. Again, just a further illustration that inferential statistics is about relationships between x and y, and there are a variety of different statistical procedures that let you test that relationship.